Section 4.4 is about multiplying polynomials. I actually do recommend watching this section before you watch section 4.3. That's why I put it first in the playlist, because some of the skills we're going to learn in section 4.4 we utilize in 4.3. So to multiply monomials, right, those are polynomials of a single term, as long as they have the same base, we multiply the coefficients and then we multiply the variables. So we're going to use the product rule for exponents to multiply the variables. So you keep the variable and you add the exponents, right? Because if I had x to the 4th times x to the 5th, that'd be x times 4 plus 9, which is, x plus 5, which is x to the 9th. Wow. Sometimes I add too quickly in my head and skip a step, and I don't want to do that to you guys. So let's look at this worked out example. I have f of x is 2x and g of x is 4x squared. Then f multiplied by g of x, which is also sometimes denoted f of g of x. Notice that's a closed black dot, so it's not composition, is f of x times g of x. So I would take 2x times 4x squared. I multiply the coefficient, so I've got 2 times 4. And then I have x times x squared. 2 times 4 gives me 8. X times x squared. Remember, x by itself is x to the first power. That gives me x cubed. When we're multiplying a monomial and a polynomial, we need to use the distributive property. Friendly reminder, the distributive property. If I have 2 times 3 plus 5, and I didn't want to go ahead and just add the 3 plus 5, I could take 2 times 3 plus 2 times 5. That's the distributive property. So if I have 2x times x plus 4, that's me 2x times x and 2x times 4. That would give me 2x squared plus 8x. One thing I haven't talked about, I think, so far in this class is when we write a polynomial, we tend to write it from largest to smallest degree. Now it is equivalent if I wrote 8x plus 2x squared. They're equivalent, right? Because math is commutative. It doesn't matter the order it's in. But in your homework, it does want it from largest to smallest degree. So keep that in mind. Let's work through some examples. I have negative 10x to the 6th times 6x to the 10th. I multiply my coefficient, so I've got negative 10 times 6 and x to the 6th times x to the 10th. Well, negative 10 times 6 is negative 60. X to the 6th times x to the 10th, that gives me x to the 16th, because remember we add those exponents. If I have 7x squared y plus 5x cubed y squared, I still multiply my coefficients. I multiply my x's, and then I multiply my y terms. We're just kind of pulling those terms apart into their pieces. 7 times 5 is 35. X squared times x cubed is x to the 5th. And y times y cubed is y to the 4th, because this y by itself has a exponent of 1. For problem 3, I have negative 2 times 5y squared minus 3y to the 5th. I'm just going to distribute that negative 2, so I get negative 10y squared. Negative 2 times negative 3 is a positive 6y to the 5th. As these are not like terms, I cannot simplify this any further. Next, if I have 4x squared times 5x cubed, that gives me, we'll write out like this, 4x squared times 5x cubed minus 4x squared times 6x plus 4x squared times 7. What I'm doing is I'm distributing. That's going to give me 4 times 5, which is 20, x squared times x cubed, which is x to the 5th. Negative 4 times 6 is a negative 24. X squared times x is x cubed. 4 times 7 is 28. And I've got left an x squared.